So for number 8, the first thing we need to do is fill in the table. So we have x values, and we just need to plug each of those in for x in the equation to get the outputs that go with them. So I'll show you with this first one. So our first x value is -1. We're going to plug it in for the x's in the equation. So everywhere that there's an x in the equation, I'm going to put a -1 in parentheses. And whenever you plug in a negative number, you want to make sure you put parentheses around it, whether you're writing it on paper or in the calculator. It's not going to come out right if you don't have those parentheses. So when we square -1, what that means is we're multiplying -1 by -1. And whenever you multiply a negative by a negative, you're always going to get a positive. So that's going to give us +1. And then here we can think of this as -6 times -1, which again is going to be a +6. And then we have the +5. And adding those all together, we end up with 12. So when we plug in -1, our output is 12. You can also plug them in on a calculator. You don't have to work it out by hand. So just to show you how that would work, if I were going to plug in -1 for x with the calculator, I would still use parentheses, put in the -1 for x. To square it, I would press the x squared button, and then I would have -6, and again, -1 in parentheses where the x was, +5, and I get 12 as my output. And so I would just keep doing that. Like next I could do 0 squared, -6 times 0 plus 5, making each x 0. I get 5. And I'm just going to go ahead and fill these in so you don't have to watch me work each one out. So the other ones that you should get are these. And then once we have all of those outputs, we are going to graph these points to see what our function looks like. So on my graph, I'm going to have the point -112. That's not going to fit on my graph because my y-axis only goes up to 5. So I'm not going to put that one. But then I have a point at 0, 5 that I can put on here. And then I've got one at 1, 0. And then 2, -3. 3, -4. 4, -3. 5, 0. And 6, 5. And then this last one, again, isn't going to fit on my graph, and that's okay. So we can tell we have a nice parabola here. And I'm going to go ahead and sketch in the parabola, make it a nice smooth curve. And we know that parabolas go forever. So I'm going to put arrows on both ends here to show that it's going to continue going up forever. And then we're going to describe our graph. So one of the things we want to say when we describe is just the shape of the graph. And we know the name for this shape. We know this is a parabola, so we'll just say that. It is a parabola, and we want to say the direction it opens. So the way that this opens is upward. So we're going to say it's a parabola opening up. We want to say whether it's linear or not. It's not a straight line, so it's non-linear. And then we want to say if it has a line of symmetry, which parabolas always have a line of symmetry. And it's just going to cut right down through the middle of the parabola where there's like a mirror image on either side. And we can use a dashed line to show our line of symmetry. So I'm going to say, and I'm actually going to be specific and say where this line is. This is actually all the points that have an x-coordinate of 3. So the equation for that line is x equals 3. So I'm going to say x equals 3 is the line of symmetry for this parabola. And then I'm going to say my x and y intercepts. So this actually has 2 x-intercepts. So x-intercepts are points where it crosses the y or the x-axis. So I've got one right here at 1, and then another one at 5. So my x-intercepts are at 1, 0, and 5, 0. And then I also want to say where my y-intercept is. So For my y-intercept, there's just one where it crosses the y-axis, and that is at 0, 5. And then down here, it asks us a couple other questions. So it asks whether this is a function. So we're going to say, yes, this is a function. And one way that we know is that it passes the vertical line test. So if we would imagine drawing a whole bunch of vertical lines going through this, each line would only hit the parabola at one point. So you would never have an x value with two different y values. And so it is a function because it passes that test. And then it also asks us to state the domain and range. So I'm going to put a capital D for domain. And so remember that domain is basically the x values of all the points on the parabola. So we want to think of each little point on the parabola and what its x value would be. So if you're at a certain point on the parabola and you kind of imagine just going straight down to the x-axis or straight up to the x-axis, that kind of helps you see the x values that all the points have. And if you think about it, with this parabola, because we've got these arrows, and the parabola is never going to go straight up. It's always going a little to the right here and a little to the left here. So it's going to do that forever, and it's going to end up hitting every x value on the entire x-axis. It's going to go forever to the left, forever to the right. So to say our domain, I'm going to put x in the middle because domain is the x values. I'm going to put the lower limit of the domain, which would be negative infinity because it goes into the negatives forever. The upper limit would be positive infinity. And then I'm going to use inequality signs to say that x has to be between those two values. So basically, x can be anything. All x values will work in this function. And then for the range, I'm going to put a capital R for range. And then range has to do with my y values of my points on the parabola. So we want to think about how far it goes up and how far it goes down. And to think about range, you can kind of look at a point on the parabola and then go over to the y-axis horizontally to think about the y values of all of those points. So if we think about that, for the whole parabola, the range is not going to be every possible number because there is a lowest point on the parabola. So its vertex right here, that is its lowest point. It never goes any lower than that. But then it does go up forever. So it has a lower limit, which is the y value of -4. Never goes below that. So we're going to put -4 as our lower limit. We're going to put y in the middle because this is range. But then our upper limit is just going to be infinity because it goes upward forever. So y has to be less than infinity, and then it has to be greater than -4, or it can actually be right at -4, so we're going to put the little equal to. So that is how we would write our range. And while we were talking about that, I realized we forgot to say where the vertex was in our description, because the vertex is a special point. So we want to say that up here. We want to say the vertex is at the point 3, -4. So the vertex on a parabola is either the highest point or the lowest point, depending on which way it opens. This one, it's the lowest point. So our vertex is at 3, -4.